Friend, this is Mr. Bilal. Today I want to talk about a small topic in physics, that is the vectors. And the particular vector I want to talk about vector subtraction, because I have seen a lot of students having misconception about this topic, vector subtraction. What actually vector subtraction is. Basically, there is no concept of vector subtraction in the real physics. I would say vector subtraction doesn't exist in the real physics. Basically, what I was doing in the vector subtraction, we are just adding those vectors, but direction of one vector is reversed. Okay, direction of one vector is reversed. Basically we're adding, but we're reversing direction of one vector. Actually we're not subtracting any vector, we're just adding those vectors in reality. I will show you, what really happening in those vectors. Let me give you an example. For let's say for an example, I have here two vectors. Okay, I have two vectors here. Let एक second, one second. As you all know that this is, suppose this is difference vector, so far called as your subtraction when you do vectors. What is the formula? That is the under root of a square plus b square minus 2ab cos of theta. This is the formula, general formula that you all guys know, है ना? Everybody knows this formula. But what is the actual why we derive this formula, and what is the actual concept behind this formula that we are using in the physics? Let me explain, guys. Basically vector subtraction, like we do a minus b, that is this thing. Okay, this doesn't exist in the actual physics. Okay, basically what is happening here, let me explain. Suppose you are doing 3 minus 2, it's 1. Okay, here you can see there is no directions. It's like simple algebra. There is no vector addition, vector subtraction, there's nothing like that. There's just simple algebra. Okay, but when we are talking about vector subtraction, you guys know that vector subtraction, vector word is here, that means direction will be there, concept direction will be there. Okay, so basically what we are doing, suppose we have a vector. Okay, we have vector, suppose we are doing 3. Okay, but we are doing addition. Okay, and I will explain what I am doing here. Just tell me that is the same one. And okay, I will explain what I have done here. Okay, just take an example. We have two vectors. Okay, we have two vectors, anti-parallel vectors, angle between them 180 degree. We have two vectors. I have a vector that is going towards north, okay, its magnitude is 3 newton, 3 newton, going towards north. And I have another vector. Okay, I will say -3. Another vector, I have -3 newtons. This minus sign, what is the here, this minus sign? This minus sign denotes that we have another vector that is going towards the opposite direction of the particular vector. That is opposite of this vector, and opposite of this vector will be like towards south. This means the -3 newton is that this sign is particularly denoting the opposite direction of this particular vector. So what we are doing there, suppose we have vector, we are doing 3 we trace this, and we are doing addition, but we have the magnitude, and we have the direction of opposite direction -3. Actually we are doing minus, subtraction, plus minus minus. That's, we did this subtraction, but actually we're not doing the subtraction, we're dealing with the directions, we're dealing with the signs of that particular vector. This is really what is happening there. Okay, so why this formula came? Okay, why did this formula came? This is the concept. Okay, just take two vectors. Okay, just take two vectors. This is the vector 1. Okay, a vector. We have another vector, suppose this is b vector. Okay, this is the angle between them theta, this is the b vector. Okay, simply if we do addition here, in integration, what we do, simply we will do like this. This is the a vector, this is the b vector. By parallel shifting, you guys know that this is the resultant vector, that is a plus b. You guys know that. Okay, there is nothing rocket science here. But what actually happens in vector subtraction, this is the, we reverse the direction of one vector. Suppose this was the a vector, and this b vector, I will reverse the direction. It will be like this. When I did this, its direction get opposite, that's minus sign came here. I opposite direction of one vector. Okay, this was the actual vector, and direction opposite, this will be the angle, that will be 180 minus theta, and this will be the a vector. Okay, what I will do there, simply I will a minus b, that is a square plus b square plus 2ab cos, what is the angle here? The angle is 180 minus theta. This is the angle here. Okay, so what I will do here, you guys know that cos 80, cos 180, it lies in the quadrant, second quadrant, where cos theta is negative, so there will be minus cos theta. And you know this 180, that its sign will not be changed, it will be cos theta. Okay, therefore I will be writing here a square plus b square plus 2ab cos of theta, cos of theta. Here that cos of theta becomes minus cos theta. Okay, minus cos theta, and the minus sign will turn there, and that is the actual, that is okay, minus 2ab cos of theta. This was the equation, this was the formula here. Okay, hope you guys understood what I tried to understand you guys. Okay, this is the thing, because vector subtraction is not cumulative, it's not associative. Okay, as compared to vector addition, that is cumulative, that is associative. Thanks.